Welcome back to the second half of our technical program. We begin with our RISC-V ecosystem panel, From Edge to Cloud. Our moderator today is Daniel Nenni. He is the founder of SemiWiki, the definitive online resource for SoC engineers creating designs for leading-edge processes at major foundries worldwide. Daniel has worked in Silicon Valley for the past 40 years with semiconductor manufacturers, electronic design automation software, and semiconductor intellectual property companies. Daniel is a blogger, author, speaker, and podcaster with a strong following on multiple social media platforms. The panel will discuss how the ecosystem supports the user-extendable RISC-V ISA. You've already met our first panelist, John Min. Each of the other panelists will now introduce themselves, starting with Chris Jones, IoT Director of Applications at Crypto Quantique.
My experience starts from the late 80s, I guess. I have a degree in electronics and started off in military avionics design. Did that for a few years, got a bit bored and went into semiconductor industry, started to work with Cypress Semiconductors. So it's nice to be back home. So I've been up in San Jose several times. I was with them for 12 years, selling MCUs across Europe as an FAE. And then I moved to Renesas. I was there for 6 years, again, field apps, Europe. And then I went to security. So I was a couple of years with Secure Things, or IR Systems, who owns them now, based out of Cambridge in the UK for a few years, and now with Crypto Quantique. So too many years in the industry.
Thank you, Chris. Kat?
Hello, my name is Kat Shi. I'm with Imperas software, and my background was in computer science. I started out working for an ASIC company building EDA software, and then I thought my product is so amazing that I went into sales and marketing to sell it. And I moved into the embedded system side about 15 years ago, and have worked for companies like QNX Software, Wind River, and Hewlett-Packard Enterprise.
Thank you, Kat. Dwayne?
Hi, I'm Dwayne Gibson. I'm a field applications engineer with 27 years of industry experience. I work with IAR Systems out of Plano, Texas, and I manage the central and western region as an FAE. I, in the past, have worked as a hardware developer and FAE with Future Electronics for 25 years and Avnet Electronics Marketing for 5 years. I've been with IR now for about 3 years and really appreciate the opportunity to attend the RISC-V Forum and meet with you all today.
Thank you, Dwayne. Max?
Hi, my name is Max Hinson. I am Lead Technical Marketing Engineer at Green Hills Software. I've been with Green Hills for about 8 years in the Business Development Group, doing a lot of different things from working with our hardware and software partners, doing technical marketing activities, and some product marketing as well.
Thank you, Max. So let's talk about the RISC-V ecosystem. Ecosystem is very important for all industries, but specifically for the semiconductor industry. John, can you talk about one of the challenges you see in the ecosystem that we're facing?
So, thank you for the question. So we're the, and this is a CPU company. The C stands for Central. All the road leads to RISC-V, a CPU. The ecosystem-wise, in a way, the challenge now is we have too many ecosystem partners to startup. From my point of view, I get contacted by ecosystem partners practically every day or more than once a day saying, we're creating something new. Can you evaluate? Can we test on your processor? So challenge from my standpoint is helping test, optimize, and make a coherent ecosystem.
Okay. Chris?
From my viewpoint, the ecosystem, we're looking at the security side, of course. We're a security company. So we're trying to help customers implement security in products, using cores, and ensuring that they can keep the security within that device from the start of design all the way through to linking to a cloud application, for instance. So we're trying to make sure that that customer can implement security in those kind of products, what we call zero trust, which I'll talk about later. So this is where the customer doesn't need to trust all the companies that are in the supply chain and other ecosystem partners within that chain. So that's the challenge we face, and that's the one we believe we are solving with our products.
Kat?
I'll share a little bit about Imperas' involvement with the RISC-V ecosystem as background. Imperas was founded 15 years ago. We built virtual platforms and simulation software for embedded systems. We supported 14 ISAs. So when RISC-V came along, we quickly built a processor model for RISC-V. That was 2017. And in 2018, we supported Andes as our first RISC-V processor. And the end of that year, a big data center customer was developing their software for AI SoC using Andes processor and our platform. And that was the first vector processor that Andes released to the world, and that was in 2018. Since then, we've been supporting Andes. We supported other folks in the ecosystem. We also thought that we can add a lot of value to the ecosystem by contributing expertise in the areas of compliance. So we also quickly joined the RISC-V International Compliance Working Group alongside with Andes. So that was a lot our contribution there. We also contribute open source products and commercial products, of course. So what do I think is the largest or one of the biggest ecosystem challenge? I think it's to build a vibrant and rich software libraries layer. I'm glad to hear Intel talk about the one API, but if I compare what RISC-V have right now, compared with the ARM ecosystem, there's still a lot of work to catch up. Let me use two examples to illustrate that. So 12 years ago, Linero was founded to create an open source consortium for ARM, right? So there were a lot of members involved, and it was aimed to build a layer, a standard of kernel security and tools. So 12 years later, it's estimated that well over $100 million have been invested, including or in addition to the time and effort contributed by the members company. And so that is very, very successful consortium. Another example is what ARM calls CMSIS. It stands for Cortex-M Software Interface Standard. And that was founded 18 years ago when Cortex-M3 first came out. It's aimed to make the application software reusable across many different processors. Now they have thousands of software packs. What I'm trying to get to is that the army of application developers, they're very used to a rich and deep set of libraries, code examples, and I don't think RISC-V has that yet. We have made a really good start, but these are grunt work that needs to be done by engineers to get to somewhere that's close to that kind of expectations.
Thank you, Kat. That was excellent. Dwayne, the bar is set pretty high.
Yes, it is. Thank you, Daniel. And I tend to agree with you, Kat, on that. With IR, our product, the Embedded Workbench, was the first commercial IDE to support the 8051 architecture introduced in 1983. So we have a rich background in development from a compiler technology as well as from an integrated development environment and debugging technology. We support over 23 architectures to this day, with RISC-V being the latest commercial development that we've introduced to the market. So from our perspective, some of the things that we feel are challenges to the RISC-V ecosystem are certainly the software interfaces and the standards that are out there for customers to do development. But with that, there's a lot on the open source in the GitHub and open development environment. And so we're working strongly to develop tools to help customers adopt that software and utilize it within the IR Embedded Workbench for RISC-V. There are many custom instructions, as an example, that you can use to accelerate algorithms and development. And so we make it easy for customers to use those custom extensions in the Embedded Workbench. But one of the real challenges we feel is how it actually scales out to commercial adoption, and how Andes and companies like Andes and the RISC-V architecture are allowing customers to bring the mass production, the volume production that's required, the scalability that's required to actually realize products to the market. So what we're offering our customers that are commercially evaluating the RISC-V architectures for both 64 and 32-bit ICEs are the opportunity to come with an evaluation of our tool for 14 days. No code limit. It comes with an integrated CSTAT static analysis tool. So if you're in specific industries that are requiring functional safety development, such as medical or automotive or industrial, we have a platform that can allow you to scale from a hobbyist market all the way to a full-scale functional safety certified market. So in doing so, we help customers to overcome some of these barriers to adoption. And we plug seamlessly into modern workflows such as GitHub and GitLab, where you can find these open software code development. So that's what we feel are some of the challenges to the adoption of RISC-V. But of course, we need you as a community to contribute. So join in, join the seminars like the opportunity that the RISC-V conference that Andy's putting on today, and ask us questions, innovate with us, collaborate.
Thank you, Dwayne. Well done. Best for last, Max?
I'll try. So for Green Hills, a lot of our customers are building applications that require high levels of safety and security certification. And so those are the kinds of customers that we've seen at least slower to adopt RISC-V architecture. And that, from our perspective, creates a challenge because we're trying to develop software development tools and real-time operating systems for those kinds of customers. And without some customer direction, it's easy to look at the RISC-V architecture, its flexibility, its extensibility, and see a pretty daunting challenge. But we are going about solving that by adding extensibility into our compiler and toolchain, as well as making some custom instructions work out of the box on our operating systems. And so we're bridging that gap until we start to see more military, aerospace, defense, automotive customers adopting RISC-V in their safety and security critical applications. So it's going to be really, really interesting to see how this evolves going forward, and we're really excited to see the announcement of the N25F SE core from Andes that's going to be ASIL B certified.
Great. Do we have questions from the audience? I certainly have questions, but I was going to offer them up to you first. While we're working on that, I just have a quick question. John, is the 32-bit and the 64-bit implementation, is that two separate ecosystems, or is that able to live together?
It's for RISC-V, the nice thing is the 64-bit architecture is a superset of 32-bit, so that they live together. I could have a 64-bit processor but still run 32-bit application. And even 16-bit dense applications as well. So they, as all the ecosystem coexist, work together very well.
But the Panelist thought about preparing for the chiplets. There's a lot of, we talked about the three dimensions of it, how do you interoperate, protocol, things like that.
That's an excellent question. The question is about chiplets. Chiplets is really a big thing. It could cut design time, cut design costs. Where are we at in regards to chiplets in the RISC-V ecosystem? Anybody?
In some ways, I'll take this for now.
Sure.
In some ways, as an IP company, we're one or two steps removed from that. So, but our customers who are designing with chiplets, it gives them opportunity for creating bigger chips or more functionality into one chip by using chiplets. And I think being able to upgrade different portions of the chip separately gives them more flexibility, ultimately have a chip that's high functionality, more flexible, a quicker time.
Other chiplet comments? Dwayne?
Yes, thank you. And I'd like to also add to the comment about the 64 or 32-bit ICEs. So as it relates to the IR embedded workbench for RISC-V, we support both 64 and 32-bit ISA, both the standard, the base, and the non-standard extension. From a chiplets perspective, we also support many different silicon vendors, as well as a generic model core. From a multi-core perspective, we can support asymmetric as well as symmetric multi-core processing, and support up to 8 cores simultaneously in our debugger. So from one project environment, you can kick off 8 debugging sessions simultaneously. And this allows you to, for one, have multiple monitors so you can have a good capital expenditure with your IT group, but also allow you to see many system views and correlate that system view within the same debugging environment. So from that perspective, I think that the ISA, as it relates, is going to be really important. Connecting over that JTAG, having access to all of the cores, the registers, and what's going on in real time yields not only the security that you were talking about, but also the confidence from the debugger that the software that they're deploying is going to work the way it's supposed to every time.
Any other comments on the 3264? I forgot to give people opportunity. Or chiplets? Panel? No?
Mention chiplet quickly. We are asked by customer to investigate the protocol between chiplets. I think it's UCI. So that's something that we're looking into. At Imperas, we have definitely supported customer tests PCIe. I don't know if that's very much a comparison, but so we do have that kind of projects going on.
Other questions from the audience? I have another one, if anybody? The conference, we're talking about edge to cloud. Can RISC-V really scale from edge? Edge is a no-brainer. Can they scale to the cloud? Everybody's nodding. Yeah, okay. How?
Oh, so I'll take that one. So I think that the answer is absolutely and emphatically yes. From the standpoint of a performance per watt standpoint, the RISC-V ecosystem, the RISC-V architecture is meant for that. With its fast computational capabilities and low power extensibility, it's great. Also, from a custom instruction standpoint, it's really good because you can make targeted instructions for that particular application and not waste time or power consuming cycles for things that your application doesn't need. So you can make a target processor specific to your application and implement the software such that it addresses the problem that you are seeking to do in the IoT. So from an edge to IoT standpoint, I think it scales quite well.
Any other comments?
Yeah, sure. So one of the things we're trying to help with is allowing customers to scale their products and connect them to the web. Typically, we find you'll do some prototypes and you'll provision some devices, secure elements, something like that with cloud service certificates and get them connected to the cloud, do some prototyping, experiment with your product, get it up and running. And then once you get into some sort of volume, so say a customer starts ordering large volumes, then it's much more difficult to scale up. Typically, the engineer is kind of provisioning the device or programming maybe with certificates. And when it comes to 10,000, it's just not scalable. So one of the things we're helping with is actually allowing that to happen, to allow large volumes of devices that need certificates and keys to connect to cloud services, because it is a complex task to connect an embedded design to the cloud. And we're basically helping to scale it up by provisioning these devices at high speeds and without having to have engineers sort of basically touch the device, hence the zero-touch approach. So yeah, we see it scaling.
Good. I hope to see it. One of the issues that I see keep coming up on SemiWiki, we have a lot of discussions about RISC-V, is fragmentation. So with Intel 86, there's no fragmentation. One company, hyper control. Even ARM, pretty controlling. RISC-V is a community. Is there fragmentation? Is that a problem? John, you want to start?
Yeah, so the fragmentation is a concern, and some of the ecosystem partners we interface with have this issue as well. Actually, even Intel has fragmentation issues. Microsoft issues patches for AMD version of x86 once in a while, as well as Intel versions. The key with RISC-V is the baseline implementation. Fundamentally, the baseline code works all across the board. The custom extensions, because they're custom extensions, fragmentation is guaranteed. My custom extensions is not going to be same as other RISC-V vendors' custom extensions. But being it's a software that's widely available, you perhaps program for the baseline and application-specific code, you write it for any custom-specific processor. So RISC-V was philosophically good this way. You have the compatible world, and then you have the more accelerated application-specific world.
Max, comment?
I think that so far, at least in the early days of RISC-V, we've seen fragmentation both in terms of lack of standardization for different SoC components, as well as on the custom extension side. And I think we're starting to see this getting better. More standardization and more use cases for custom extensions. The more use cases we can look at, the more we can draw conclusions on trends and be able to support those types of extensions more out of the box.
Fragmentation?
As an IP supplier, we don't get too involved with that kind of side of the RISC-V IPs. So, yeah, something that we don't see too often. We're basically trying to build a crypto environment for RISC-V cores. So we're kind of a little bit out of scope for that.
So 32-bit and 64-bit is the same for you, or you have two different markets there?
So it's the same for us because it's basically a security block that we provide, which gives you the cryptographic keys to give the device identity. So we're very much focused on giving each individual RISC-V core that we're building has a unique identity. So whether that's from a 32 or really as long as we use that unique identity for each individual part.
Good.
And then that follows through its life cycle. It basically follows the identity and adds to the zero.
Any other comments from the panel? Fragmentation?
So John actually brought up an interesting thing that triggered my mind to think to tell you all this. So as it relates to the embedded workbench and the Andes product, we actually have non-standard extension support for the X-Andes DSP and the X-Andes performance extensions to work with the Andes Star DSP and the Andes Star V5 CPUs to enhance your performance. And so from a fragmentation standpoint, that's going to help specific with the Andes silicon, but it's also going to help across the board as it relates to the IoT, as it relates to in November with our version 3.11.1, we're going to release an X-Codense extension that could help to make your code up to 12% more dense. So filling into IoT edge-based products that was going to allow for a cheaper implementation of that microcontroller using less flash and RAM space. So that's one thing. And as it relates to the custom instructions, our inline assembler will allow you to write your function custom instruction, and the CPU, the compiler will generate the opcodes necessary to execute that instruction. And then you can just basically include that intrinsic like macro function or intrinsic like function into a header file and just reuse it from application to application. And so regardless of your custom RISC-V implementation, your code will be portable from that perspective and won't break software compatibility from a C or C++ program.
Any other questions from the audience? Oh, I have more, don't worry. Oh, absolutely.
Fragmentation comes with the freedom of innovation, and that's the beauty of RISC-V, is the freedom to innovate. And let's remind ourselves that Android also has fragmentation, but it's managed. So I think when we, as a community, we are concerned, aware of that problem, and it will be okay.
So on SemiWiki, we track the architectures, ARM and RISC, and then we track the applications, automotive, IoT, AI, mobile, HPC. Where are your success stories? What markets? Why are you successful? John, just give us one. I know you have so many.
Yeah, so we've been very successful at the edge with standalone devices. We're actually being really greatly successful at the data center, where our vector processor is really ideally suited for multiplication, duplication. So you could create a single vector processor module and replicate it multiple times in very high-end processor, especially using our streaming port. You could tightly couple accelerators and design a very high-performance AI engine chip or system from smallest to biggest. It's very scalable.
You see HPC traffic for RISC. So you're absolutely true. Do you have one, Chris?
Yeah, sure. We're in between sort of the very low-end sensor kind of devices that are connected, between those and kind of like the Linux boxes that are running sort of higher-end, I guess, connected devices. So in between those two, you get a reasonable high-performance device that can handle, say, TCP/IP and a TLS stack. Those are the things where we've been quite successful. So that kind of mid-range, where customers want to scale their connectivity of those devices to cloud services and want to manage the security as quickly as possible and as simply as possible as well. And that's where we come to for making security simple. So that's kind of the range where we're seeing a lot of growth.
How about you, Kat? Quick success story?
Our views probably match Andy's views a lot. We see it from edge to cloud. We have lots of joint customers using NX27V and also A45 series for control processor. We see customers also on the IoT side replacing Cortex-M0 with RISC-V.
Dwayne, you have one.
Well,
Only one.
we cover all industry segments, but I would say that we're having geographical success in many regions with the RISC-V architecture. In the U.S., predominantly automotive is where we're seeing a lot of success. Offload compute, embedded applications there for sensor deployment, multi-zone passenger comfort as an example. But we're seeing across the spectrum industrial, automotive, and medical.
Max?
Yeah, we've heard some nice wins in our markets as well, focusing on safety and security. Customers of ours still need safety certification for the tool chain, for the real-time operating system. The same things that they've always needed, but 5 years ago, maybe they would be using an ARM core. Well, now, some of them are starting to switch over to using RISC-V cores, and they still have those safety and security needs. And so, while it has been slower, we are starting to see those kinds of customers starting to switch over to RISC-V, and it's been very encouraging.
SemiWiki, it used to be IoT, but over the last 6 months, I just looked, automotive. We have over 100 automotive companies looking at RISC-V stuff. That's impressive. I didn't even know there was 100 automotive companies. Automotive suppliers. Are there other questions? I do have another question. It's about the extendability of RISC-V. Very important. We know it from ARM. Can you comment on the extendability? Maybe start with you.
Two words there in that world that we need to worry about is one is configurability. So how has CPU IP vendor given you enough option to configure the processor optimally for your application? Second one is, as we talked about, custom extendability, where you could you could create things that are beyond what's configurable. So we support both. I want customers to use configurability we gave them to optimize their implementation and have the freedom to go out and create something even better. Something only they would use to accelerate their application, whether it be more performance, less power, or perhaps more security. Use my custom bus, a stream port to isolate data traffic from the main system bus. Nobody else sees it but the processor. So so the two domains that we deal with is configurability and extendability, and I personally think they're completely different things, but can be used effectively by customers.
Comments, Chris?
Yeah, thanks, John. That kind of answers my bit. Yeah, the extendability, because our IP block, we need to isolate obviously the seeds from our identity IP block from other parts of the system buses. So extendability really helps us, and also helping customers develop different types of roots of trust, which is typically what our other tools support. So yeah, we love the extendability of the RISC-V, and it certainly helps us in implementing our IP in customer CPUs.
Kat?
We see that a lot. I think all of my customers, they want to customize their core. And we built a methodology for them to easily do that. In fact, my colleague, Manny Wright, will talk about that methodology, the integration with Andy's ACE tools this afternoon.
Dwayne?
Well, from a development perspective, the way IR systems use extendability to the RISC-V ecosystem, from our perspective, is expanding it out to developers who are looking to adapt to modern development workflows, such as using Visual Studio Code or maybe Eclipse, along with modern workflows like Docker or continuous integration environments. And so we easily bolt on to those type environments. We provide the IR build tools to stand alone and scale and high automation build, test, and integration and regression testing. We also provide simple to use macros that can be deployed through our debugger. And for those developers who are seeking development ahead of hardware, we actually license our 64-bit simulator from Imperas, thank you, as well as provide a 32-bit simulator for the ISA, RISC-V ISA. So you can get ahead of your development software team prior to your actual hardware arriving. So we try to look at development as a holistic approach and make it simple. So come look at the embedded workbench as a fully contained development environment, or if you enjoy utilizing Visual Studio Code or any of the IDE plugins like Eclipse, utilize that.
Max, extendability?
It's really exciting to see what everyone is doing with extensibility, custom instructions, especially in the consumer space where we're not as active. But we can imagine how those use cases will end up propagating over to safety and security critical applications. And so looking into the future and seeing where our customers may be going with this, we've started to add support for this kind of extensibility into our toolchain and compiler, as well as on the operating system side, to help our customers at least start prototyping in that way. And then we can grow along with our customers in terms of fully supporting the kind of extensibility that they need going forward.
I have one more question, then we can do final thoughts. But when you're working with customers, are they replacing ARM designs, or are these new designs, or what type of projects are they doing? Not you, John. We'll start with you, Max.
Sure. Yeah, we're seeing all of the above. Sometimes it's ARM application cores that are being replaced by RISC-V application cores. Occasionally, sometimes it's a RISC-V DSP that they're adding. Other times, it's a smaller 32-bit core that they're adding to an ARM A core. We're really seeing pretty much every combination you can imagine.
Yeah, so of course, right now, the state of the industry, this is the perfect storm. So chip shortages are prevalent. And so, we're getting all of the above from the standpoint of migration from 8-bit to 32-bit, from migration of ARM to RISC-V, or from even other 16-bit architectures up to RISC-V. So the ability for the customer to use a common development platform allows them to feel more confident and able to focus on their application. They don't have to worry about the tool chain inducing problems that they hadn't seen while they migrate. We also are providing tools like the Embedded Workbench Project tool to allow you to pull in your project structure into our environment, handling 80% of the workload of getting a RISC-V project up and running. So the chip shortage has posed a lot of issues. Because we support so many different compiler technologies, the customers are coming to us because they know us and can rely upon us. So.
We're seeing a lot of designs in a data center that's using RISC-V as minion cores. And we also see the replacement of Cortex M0, M3s.
Yes.
As I pointed out, the area we're particularly focused on, we're seeing a lot of movement to RISC-V due to the low power and performance you get with the cores, definitely.
Power is critical.
Yeah.
John, final thoughts.
Our thoughts are the RISC-V is doing really well. Nice thing is, as my partners here have mentioned, a lot of our design wins are replacing ARM. However, RISC-V is maturing enough that Andy's lot of design wins are also second, third generation designs of RISC-V. So whether they're second, third generation of Andy's cores, or we're able to compete and displace other RISC-V cores, we're doing well. RISC-V is doing well, and Andy's has a unique offerings that are fitting well designed.
I agree. I would definitely put you guys in the leadership. Chris?
And the excitement around RISC-V that we're seeing, it's new, innovative. It allows customers to be flexible, and with the power performance that it is providing us, we're seeing a lot of excitement in the industry over it. It's going to be good.
Kat, exciting times?
Exciting times. We get lots of leads on RISC-V every week.
How big of a business is it for you guys? Is it growing double percentages, or RISC-V versus the other architecture that you support? How about you, Dwayne? Final thoughts?
Well, RISC-V is quite exciting. We've actually launched an autumn webinar series, and RISC-V is featured in it. So from a core mark perspective, we're showing the ability of the RISC-V to handle the performance demands that the industry has upon it. Also from an ultra low power benchmarking perspective, you can take a look at some of those. So the opportunity is there. I think it's prime, and I think it's time for the adoption to really see the ramp up.
Yep. I think that these are maybe early days in a lot of the safety and security critical industries for RISC-V, but RISC-V will be there in the future. And so we're excited to be able to work with everyone here, as well as with our customers in building that future.
I agree with that completely. I work with the foundries, and it was amazing to see the foundries stand up and say, RISC-V, 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 Intel, TSMC, everybody. It's incredible. So that's the time we have. Thank you very much for listening, and have a good day. Thank you, panelists.